Okay. So our next topic is generalization, specialization, and aggregation in ER models. So let's start with this. Yeah. Last lecture I showed you this and I gave you one question. Hmm. The question was student has name, ID, and address. Professor also has name, ID, and address. And staff also has name, ID, and address. So what will you do in that case? All three have same attributes. Will you write it three times? Or will you do it like your Java? Like this, class person and class student will extend person. So here comes the concept of what? Inheritance. Yeah. So in ER models also, in databases also, they can also inherit. A database can also inherit. So here we will do the same thing by utilizing some additional functionalities of ER model. Correct. That will be specialization, generalization plus aggregation. So why uh, why we are doing this? Again, the same thing. So that we have to inherit some properties, some attributes, I would say, because the term here is attribute. We have to inherit some attributes from the parent class. Yes, that's why. So same we are going to do over here. Let's see how these things will happen. Fine. We'll go one by one. So first one is specialization. So imagine here your college database has one entity set. That is what? Person. Okay. So college has one entity set that is person. This one. It is having some attributes. Person ID, that is your key attribute. Key attribute. Name, address. Okay. These are some attributes. And then you notice something. Some of these people have CGPA. That only makes sense for students. CGPA only makes sense for students. Then you observe that some people have designation and salary. So who will come under that part? Designations. Yeah, professors. Okay, correct. You can think of staff also, but staff is not just the teaching staff. Staff is other non-technical staff also. Correct. So then there is a support staff. They will be working in different shifts. Yes, they will have a shift. So they have their own attributes, but they all will have some common attribute, which is name, person ID. Each one of them, even the student will have a student ID, that is person ID. Student will have a name. Professor will have a person ID. Professor will also have a name. Staff will also have a person ID and name. So these are those attributes which these other entities will inherit from the upper class. Yes, from this super class, I would say. Yes, so here what is happening? It is called as specialization. Going from general entity, going from general entity to special entity. Okay, going from general entity to special entity. And the notation is a triangle. That means you have to draw one triangle and you have to write is a. So person is a student, person is a professor, person is a staff. That is the meaning. So this triangle points up to the parent. Correct? I hope you got some idea. This is called as specialization. So each child entity keeps person ID and name and address, and they can add their own attributes. Student will add CGPA, professor will add designation, supporting staff will add shift. That is the meaning. Now let's see next one. Next one is generalization. That is exact opposite journey of the previous one. This time you have to imagine that you did not start with person. Okay. You have to start from the child node. Okay. So here one thing you have to understand the difference. Specialization, that person already exists and it splits up into student, staff, like that. Top to down. So it is going from top to down. Now we have to do opposite of that. Yes. So opposite will be bottom to up. Bottom to up. So here you will start from a particular staff, student. They are already existing, and then pull common attributes into person. That is the meaning. Okay, correct. So what is happening over here? Somebody build a student table, somebody build a professor table, somebody build a staff table. Three separate entities are already existing in the database. So built at three different times. Then one day you look at them together and think, all three have name, all three have IDs, all three have address. So you pull those common attributes up into a new parent called person. That is called as generalization. So it will work from bottom to top. That is the meaning. Let's see. This is the one. Okay. So the whole point here is this time, if you'll observe, the triangle is upside. Yeah. This time the triangle is upside. So here it is inheriting, taking the properties from these already existing databases, tables, and merging them as one common entity, that is person, which is having common attributes name, person ID, and address. Okay. So it is also utilizing is A, but here the triangle is upside down. That is the difference. Okay. So specialization basically asks what kind of person exists, and generalization asks what do these three have in common. So in this way you have to segregate and you have to represent your answers, the diagram. Okay. And from the exam point of view also, this is very much important. It has been asked a lot of time in the exams. It can be asked for 3 to 5 marks question. Correct. Now let's see here what is happening. So here basically attribute inheritance is happening. The child entity inherit the parents relationship too. If the person has a relationship, lives at address, every student and every professor gets that relationship for free. So that exactly happens like Java. The function is extends. So it works like that. Now, see, while working on this, we have to concentrate on these two parts also. So every is a hierarchy that we are discussing right now. It needs two things, and they can be asked in Viva also for sure. So first thing is whether it is disjoint or overlapping. The first one, whether it is disjoint or overlapping. So what is the meaning? Can one entity belong to two children at same time? Okay. Can one entity belong to two children at same time? Let us understand this. That means suppose if we are talking about a vehicle can be a car or truck. They are disjoint from each other. But if we are talking about a teaching assistant who is a student also and a staff also. Yes. So how it can be like a PhD scholar, you can say, who also teaches to MTech students. So they are doing two things. They are student also and they are acting as a staff also. They are overlapping entities. They are overlapping. Yes. So that is the meaning. Whether they are disjoint or overlapping. I hope you understood this part. Then next thing is um, the next part is total or partial. Now this one. Now how do we say this? Must every parent entity belong to some child? Is it necessary? If every single person in the college database must be a student, professor, or staff, that is called as total specialization. Every person, if every person, we are talking about every person, if they must be all three entities, then it is called as total participation. If not, or an alumnus, you can, if not means you can think about an alumni of the organization. If a person can exist without being any of the three, that is called as partial participation. Partial one. Okay, so that is total. and partial. So these two things we have to remember, and it becomes four combinations basically. And in the Viva questions also, it is being asked a lot. Okay, so please concentrate on this part also. Make a note of this in your notes. Yes. So disjoint plus total. There are four combinations possible now. Every vehicle is exactly one of the car, truck, or bike. Yes. Next one is disjoint plus partial. An account is savings or current account, or neither yet. Yes, or none of them. So here we are talking about exactly one. It must be, but it is not necessary. And here overlapping plus total. Like every person is a student, staff, or both. So that is again a must thing in total. Then again, in overlapping and partial, a person may be a student or a staff or both or none of them. So it is not compulsion, not compulsion. So in this way, you can think of different examples like this and you can put your answers in the comment box also. So let us see further. Yes. Now, the hardest concept in unit 1, that is our aggregation now. Okay, so suppose an employee works on a project using certain machinery is there. So three entity sets are there and one relationship is given over here. That is called as which type of relationship? We already studied it. That is called as ternary relationship, in which we have three entities and they're connected to one diamond as a relationship. Okay, so that is ternary relationships. And the name we have given it as works on. Now, Now the business adds some requirements. Suppose a manager supervises that assignment. A manager supervises that assignment. Think carefully about what is being supervised. Not the employee alone. The manager does not supervise some particular employee in general. Not the project alone. The manager supervises this employee on this project using using this machinery. That is the thing. That is the whole assignment. So what is happening over here? This manager is supervising the assignment. Yes, and it is not just supervising to supervise this assignment. What it has to do, it has to supervise this employee on this particular project using this machinery. Then that will make the complete information. So the whole assignment will be the works on relationship. That is the meaning. Now, see further what happens. Now here, you would want to draw a line from supervises diamond to the works on diamond. Yes. See what will happen in this case. Okay. Wait. So this is our this example. Correct. So what I did is I added this new entity here, manager, which is supervising this complete assignment. That is the meaning we are talking about. Correct. Now, understanding this complete scenario with this ER model. Now, what is happening here? That this manager is now supervising this complete assignment. This assignment is happening through this part of ternary relationship. That is our whole assignment going on. The entire works on relationship. So what we are doing, we have drawn this line from supervisors to works on. Yes, but we cannot do that. The ER model has no way to connect a diamond to the another diamond. We cannot connect directly this diamond to another diamond. So what is happening? So what we will do? We will utilize one complete assignment box. This box. Correct. And so that's why what we are doing, we are converting this relationship into an entity. So this complete relationship will be converted into an entity. Now it will act like an entity. Because why? Because we cannot connect two diamonds. This is not allowed. This is not allowed. So what we have done, we have converted this complete relationship as one entity and we put it in one box, and now we can connect this diamond to this box. This is the thing. Now this box will be a dashed box around the entire work zone structure, in which employer, project, machinery, and the relationship connecting them, everything will come inside it. And we declare from now on, treat everything inside this box as if it was a single higher level entity. Okay, then it is one entity, this complete box, and this is one entity. Now the connection can be made between manager and this complete entity box. So this is called as aggregation. Okay, it is called as an abstraction that treats a relationship as higher level entity. Please make a note of it. Okay, so aggregation is an abstraction. It is an abstraction which treats, please make a note of it, which treats a relationship as a higher level entity. Why so? So that other relationships can connect it. So that other relationships can connect it. So that is called as aggregation. That is called as aggregation. So say in the exam, if someone asks you this definition, so what you will write? You can utilize this part, and then you can also make a note of this part. Aggregation is used when we need to model a relationship between a relationship and an entity. Okay, when we need to model a relationship between a relationship and an entity. So that one line answer can also be there. Why is aggregation required? Okay, great. Now let's see all of them together. That is the thing. Great. So here, let us revise it quickly. A quick revision will be good. So specialization will be what? Top to down is a triangle. So generalization will be what? Bottom to up. Same is a triangle. Okay. Gather common attributes into a parent. Aggregation will be what? Dashed box. It will treat a relationship as an entity. Please remember this part, very crucial one, and it has been asked a lot in your Viva questions. Great. So I hope you got this complete idea about these additional features. They are also called as additional features of ER diagram: specialization, generalization, aggregation. So you can utilize them for that purpose also. Now it's your turn. A vehicle registry is given to you. A vehicle has registration number, owner, price. Vehicles are cars with seat count, trucks with load capacity, or motorcycles with engine cc. Every vehicle must be one of these three and never two at once. So you have to go through this, think about it, and you have 4 questions. You have to draw: is a hierarchy? Which shape will connect them? Is this specialization or generalization? Both are defensible. You have to give your justification. Will it be disjoint or overlapping? Will it be total or partial? So pause this video, answer this question, and then match your answer with this one. So the is a triangle connects vehicle into 3 subtypes. Correct. That is given to you in the question, which is car, truck, and motorcycle. Correct. That is the thing. So it will read from top to down. So it is specialization. Specialization. Fine. Specialization. So if you argued generalization because the 3 types existed first and you justified it, that is also defensible. That is also okay. You can do that. Just your justification should be there. Justify your answer. Okay, justify your answer. That will also be fine. You may think that these 3 are existing first and then you have drawn the vehicle. That is also okay. Okay. Never two at once. The question was never two at once. So it will be disjoint. Must be one of these 3. It must be one of these 3. So that will be total. Because must keep. So disjoint plus total specialization. That is the answer. That is the answer. I hope you got your answer correctly. Great. So we are done with this topic. Now, from exam point of view, there can be different questions that can be asked in the exam, like explain generalization, specialization, worth of 5 marks. What is aggregation? Why it is required? Explain with an example. Differentiate between generalization and specialization. Explain disjoint and overlapping constraints. So please make a note of these questions that will help you out in your exam. And finally, before the closing, here is a question for you. Yeah, I hope you are enjoying these videos. Please drop a comment to me, subscribe my channel, and please share these videos. It can be helpful for many students. Thank you so much for watching my videos. So the question is like what? Your ER toolbox is complete now. Yes, correct. So toolbox is finished. There is only one thing left to do with a finished toolbox. Yes. Now you have entities, attributes, relationships, cardinalities, weak entities, inheritance, aggregation, whatnot. Everything is there. It is a full-fledged, in detail ER model in front of you. Yeah. So here we will, in next lecture, what we'll do, I'll give you one paragraph describing a real system and we'll design the complete entire database from scratch. No hints. So which system should we design? In the, please comment. Drop your comment. Yes, you can think of any system which can have a database, and most of the online systems, everything is having a database. So think about it, which database you would like to design. Please drop your comments. Thank you for watching. Thank you for subscribing my channel. See you again in my next video. Bye bye.